we're going to look at how to solve a system of two linear equations in two variables using a non-graphical approach. And our first approach is going to be algebraically using this idea of substitution. Okay, there are two different methods. We'll get to the second one in the next video. Okay, with this first example though, I haven't given any instructions, so what do? The idea again is I want to figure out the x and y values that satisfy this equation. So what I'm going to do is I notice that, well, there's an x here that's all alone. If I perhaps isolate that, maybe that'll be useful. So x is going to equal 3y plus 6. Okay, and so with this relationship now, what I'm going to do is I'm going to substitute that back in to the first into the first equation. I don't want to substitute back into the one I just manipulated because I'll get like 0 is equal 0 and it's silly to do. Okay, manipulate one, substitute into the other, and so this I get 3. And then now instead of x, I have this expression of 3y plus 6. So I'm going to substitute that in. 3y plus 6 plus 4y is equal to 5. And I'm just going to do algebra now to simplify. So I get 9y plus 18 plus 4y is equal to 5. And isolating all this, so 13y on the left, 18 moves over, I get negative 13. Y is equal to negative 1. Okay, and then consequently, I found that x is equal to 3y plus 6, so I'm going to use that relationship to say that x is equal to 3. I know y is now negative 1, and then plus 6, and this yields x is 3. Okay, so now with all this, I can say the solution set is squiggly bracket, and then by convention we just list the first value of the first alphabetical variable first, and then the second one after that. Okay, so we would say the solution set here is 3, 1. Okay, and we would be done. Okay, now we jumped into this problem and I didn't tell you how to do it. We just kind of did it. So now I want you to take a moment, pause the video, and say, okay, well, what were the steps? Okay, and then see if you can identify like the steps that we took up here, and then resume the video when you're ready to see what we did. So what we did first was we isolated one variable, right? We found x in the first, or from the second equation, substituted this expression 3y plus 6 into the other equation, and then we ended up solving, right? And then substituted the value that we found, minus 1 for y, into an expression to find x. And then lastly, and I didn't do this, oops, we should always check our answer. So this is as simple as like taking equation 2 here, and we just check, okay, is 3 minus 3 times minus 1, is that equal to 6? And sure enough, it does check out. Okay, so you should always check your answer. That way makes sure that you have the right answer. Okay, now here I want you, I guess we'll do the one on the left together, and then on the one on the right, I want you to pause the video and try that on your own. Alright, so this first one, it's not clear what I should solve for exactly. Just for fun, I'm going to take the first equation and solve for y. You can pick either equation, it really doesn't matter. So if I solve for y, I need to say this is minus 2y is equal to minus 3x minus 1. Solve for y, I get y is equal to 3 halves x plus 1 half. Okay, that's fine and well. And what I'm going to do is take that and substitute that into equation 2 for y. So I have 2x plus 4 times 3 halves x plus 1 half is equal to 1. Okay, and then now I just go through and simplify. So let's see, distribute the 4 to each piece. That effectively multiplies everything by 2. So 6x plus 2 is equal to 1, and I get 8x is equal to minus 1, x is minus 1/8. Okay, then I'm going to take that and substitute that in. Y is equal to 3/2 minus 1/8 plus 1/2. Okay, let's see, doing arithmetic here, minus 3/16, and then 1/2 is the same as plus 8/16. So then final answer here is 5/16 for y. So I'm going to propose the solution set and then I'll check it. Set is bracket parentheses negative 1/8 5/16. Okay, there we go. And let's just check it. So I'm going to check using the second equation. So if I check that, I'm going to have 2 times minus 1/8 plus 4 times 5/16. Is that equal to 1? Well, I get minus 2/8, which in terms of, well, okay, leave it as that. And then plus, if I reduce this, this would be 5/4 is equal to 1. Negative 2/8 is 1/4. Negative, and then 5/4 is 1 more than 1. Simplify it, it does work out. Okay, so that's just a nice way to confirm that you have the right thing. Alright, so now I want you to pause the video, try the second example, and then resume the video when you get stuck or want to hear more. Alright, so I haven't completed the exercise yet, but here's my work so far. So first thing I did was I just kind of wanted to rework the system so it was a little easier to work with. So in the first equation, all I did was distribute the 4, and then get the variables to one side and the non-variables to the other. So I would get 4x, this would be minus 8. I moved the 8 to the other side to get 11 over there, and then brought the 6y over. Okay. For the next equation, it's actually possible to multiply each side of an equation by a constant of your choice. This is just useful to clear a fraction. Okay, know that you can do that. So I multiplied each side by 8. Again, it has to be the same constant on both sides, and that just allowed me to clear the denominator and get a nicer thing to work with. 2x minus 3y is equal to minus 4. Alright, and then I went through and did the substitution. So I solved for x in the second equation. Could have done something else, doesn't matter. And then I substituted that value of x into the first equation, and I was doing that, worked that through, and I got 8 is equal to minus 8 is equal to 11. Well, that's obviously completely false. So what we would say here is that this is an inconsistent system. Okay, and for this one, we would actually say the solution set is, and we would actually just say open, or like open and close brace, because there's nothing in there. That means there is no solution. You can also say there is no solution, but I believe Connect Math is probably going to want this language. Alright, so just be aware that no solution and this empty set is the same thing. Actually, empty set, you can do something like that too. I'm okay with that, but when you get a false statement mathematically, that just means you've arrived at an inconsistent system. Alright, so big picture here, we talked about substitution method, which really has these 5 steps. The last one, I didn't check my answer just because I don't have an answer to check. So make sure you follow these steps when you're doing the substitution method, and you should be in good shape.